So this is the setup for lesson 106's assignment using the state machine to control an ultrasonic sensor. Here's my ultrasonic sensor, that's my target, and as you can see I have it set to be just right at 10 centimeters, as close as I can get it without a board like yours. So this is the code for lesson 106's assignment, controlling the ultrasonic sensor with the state machine. Import the necessary libraries, set up the state machine. Here's the function. I move the OSR to null to make sure it's clear. I pull in from the FIFO a 4 million number that I put down here in the MicroPython function. I move that to X, and then I will set the pins high for 50 seconds, which is at the frequency I'm running is 50 clock cycles. Set the pins low, wait for the input pin to go to 1, and then here's the jump for a count. I move the ISR to null just to make sure it's cleared out. Get to the pins from the value from the pins. Move that value to Y. If that value is a 0, then I'll go down here where I take that value, move X into the ISR, clear the ISR just to make sure it's empty, move the X into it, and then push it back to Python, and then wrap. If that value is not 0, then jump back up here with a decrement, using that 4 million value we put in X, and then that value, the new value of X, is what will be returned whenever that pin goes back to not being high. I hope that makes sense. It's a little convoluted. But then here's where I substantiate the state machine, set up the in pin, set the frequency to 5 million, and make it active. And then in Python I have this distance function which sends the 4 million value to the state machine, then waits to get the number back from the state machine, divides the number it gets back, or subtracts the number it gets back from 4 million, and then divides by 2, and then multiplies by the 0.343 to get the distance. Returns that down here to the while true, where we called this function, and then printed it and slept for a quarter of a second and start all over again. And then here's the point to cleanly exit. So now I'll start the program so you can see the measurements I'm getting, and as you can see it's extremely close to 10 centimeters and very, very, very consistent each time, exactly the same measurement.